So change of gear. Again, we're into 3-step type calculations, but with a little twist to it. How many milliliters? 1.85 molar HCl. So notice not grams or moles, but milliliters needed to react completely with 46.4 grams of NaHCO3. So we know NaHCO3 and we know the grams of it. So we're starting there. But now the finishing point, HCl, is the substance, so that's the B side, but it's not grams, it's not particles, it's not a gas, it is liters of the solution. So step 1, the familiar grams to moles, step 2, the very familiar moles to moles, and now step 3, the unfamiliar, at least as far as this worksheet is concerned, moles to liters. Step 1, again, grams to moles, just make sure we use the right molar mass. And we get 0.552 moles of the NaHCO3, that's right here. Step 2, we need to have the ratio of the coefficients. Well, we tell you what the reaction is. HCl reacts with NaHCO3. Ordinarily, I would expect you to know what this is. It's a very standard neutralization reaction between HCl and sodium bicarbonate or hydrogen carbonate. However, here I was nice. Said NaCl and H2CO3. Looking at it all, everything's already nice and balanced. I should note that you never actually see H2CO3. What happens is it breaks apart to water, gives you H2O and CO2 bubbles, and so it's a very good test for acids, you might remember, but I thought let's just not focus on that here. Let's just do the carbonic acid as the product. But anyway, whatever way you do it, we've got HCl, coefficient is 1, sodium bicarbonate, coefficient is 1, very nice one, giving us 0.552 moles of HCl. And now finally, step 3, we're using the relationship for a solution, the molarity. 1.58 here is moles over liters, so pop everything in. 1.58 molar, 0.552 moles over liters. So therefore the liters is going to be 0.552 divided by 1.59. Make sure you do that rearrangement properly. Often people mess that up. Gives us 0.347 liters or 347 milliliters. Solution of acetic acid, blah, blah, blah. Titration of 5 mils of a solution of acetic acid requires 38.08 mils of 0.1 molar NaOH. How many grams of acetic acid were present? So let's go ahead and pop in the roadmap. We start off knowing about NaOH. So that's right there. What do we know about NaOH? Well, effectively the liters of a solution. So that's down here. We're asked about grams of acetic acid. So obviously acetic acid, CH3COH, is our B side, and we're asked for the grams of it. So it's 3 steps. Liters to moles, moles to moles, moles to grams. Notice, by the way, that there is absolutely no need to know about that 5 milliliters of the acetic acid solution. That's down here. Don't care about that. In this particular case, we care about the grams. Always be on the alert for useless, or at least useless in the given question, information. Pulling out the salient bits, the first step is where we go from liters to moles, and we're using the molarity moles over liters relationship. Let's see what we've got up here. For the NaOH, the concentration is 0.1, and we have 38.08 milliliters, which is, of course, 0.03808 liters. Multiply that through, and we have 0.003808 moles of NaOH. Moving over for step 2 for that nice little ratio. What's the equation? Well, again, this is a neutralization equation. I might have expected you to know that it is a 1-to-1 relationship, because here is a weak acid, here is a strong base. But if you haven't got to that part yet, no problem, because I tell you the products. CH3COH plus NaOH makes water, and NaCH3COO balances as a 1-to-1 reaction quite nicely. So pop everything in. Moles of acetic acid we don't know. Moles of NaOH we do know from the press step 1 and 1-to-1. So we got 0.003808 moles of acetic acid. And step 3, very familiar, moles to grams, using a relationship that we've used a ton of times before, giving us 0.228 grams of CH3COOH. Should point out that to get this formula, I just put everything together. So we got 2 carbons, 3 plus 1, 4 hydrogens, and 2 oxygens. Now the solution one. In its reaction, so I've been nice and actually given you the balanced equation. How many grams COH2 required to react with 10 litres of 0.6 molar H3PO4 solution? So we know about the H3PO4. We're given litres of a solution, so we're down here. We're asked for grams of calcium hydroxide, so therefore the B compound is calcium hydroxide, and we're asked for the number of grams. So the same steps as in the last question. The information about the solution to moles of the solute, moles to moles, step 2, moles to grams. So for the first step, molarity moles over litres, molarity is 0.6 litres, 10 litres, so therefore we have a total of 6 moles here of the H3PO4. Equation, we're given it, there's the H3PO4 has a coefficient of 2, the CaOH twice has a coefficient of 3, so we'll put all that in, moles CaOH twice on top with a coefficient of 3, 6 moles given, are calculated, of H3PO4 on the bottom with a coefficient of 2. So that gives us 9 moles of calcium hydroxide, and then of course to turn that to grams, multiply it by the molar mass, and we get a total of 666 grams. Always a fun number to see in a calculation. Finally, we're going to close out this section of the worksheet by moving to gases. So airbags, jolly good. Complicated equation, jolly good. What mass of NaN3 needed to provide 75 litres of nitrogen gas? So that's a volume, temperature, and pressure. So A, we know about N2, and we know about its pressure, volume, and temperature of a gas, and we are asked for grams of NaN3. So B compound is NaN3. We want grams, so we're going there. So we're going 3 steps. First of all, we've got to get to the moles of the gas, which we do using PV equals nRT. If you're not used to the gases, go watch the gas law chapter. And actually, I do this problem in the gas law worksheet as well, but never mind, nothing wrong with doing something more than once. So only once we've got moles of N2, turn that into moles of NaN3. Once we've got moles of NaN3, convert it to grams, as by now you should be doing in your sleep. Not that you should ever sleep during chemistry class. So pull out salient bits. First step, PV equals nRT. So I like to use 0.0821 for my value of R. That requires units of volume of litres or cubic decimeters, gas atmospheres per mole per Kelvin, always the same for all usual values of R. So throw everything in, 748 millimeters of mercury divided by 760 to get in atmospheres. Given the volume in litres, 75 litres, moles we don't know, that's R I've already talked about. And T 298 Kelvin, 25 degrees Celsius is of course 298 Kelvin. Multiply that out, we get 3.02 moles of N2. Now the rest is routine. Here's our little equation. Coefficient of N2 is 6. Coefficient of NaN3 is fortuitously 6. So therefore moles of NaN3 to moles of N2, 6 to 6. So we have 3.02 moles of NaN3, and now converting that to grams. 196.3 grams is what you get when you multiply 23 plus 3/14 by 3.02.